Hey y'all, CB here, the No BS welder here at NBS Welding. We're in the shop today and we're going down a road we've been down many times before. This would actually be the fourth video on this particular subject of aluminum welding that we've run into. First of all, let's take a look. This is an Italian-made cast aluminum gearbox, basically a right angle drive unit that there's an electric motor that connects right here that spins a horizontal shaft right here, and that turns a gear in here that turns this shaft down here, and that shaft down there bolts to the brushes on my buddy's automatic car wash. And this has been an ongoing problem that we first worked on in September of 2022. Now, about 10 months ago, we had boxes that were broken like this one, where they broke off right here. The cast aluminum broke right here. I was welding one of them up 10 months ago. And I welded it up, and that's when I came up with the idea of wondering if I could add a 1/8 inch aluminum plate to the bottom to make it stronger. Because at that point, it was the second time that we had gearboxes break there. And we found out that the only thing that would happen if I added an 1/8 inch aluminum plate to the bottom is that the brush would move up 1/8 of an inch, and it would have no negative effect on the way anything worked. So that's what we did. And I'm going to show you on this one, the aluminum plate, but on this particular one, you may see that the aluminum plate is the only thing that's ever been welded on this one, because what this actually is, 10 months ago when I was fixing one of these gearboxes and came up with the idea of adding the plate, I told my buddy that owns the car wash my idea for adding the plate, and he wanted me to add the plate to every gearbox he's got, because we'd already had so much trouble with these breaking. He said, man, let's reinforce all of them. So we did. So the gearbox that I've got right here, this is one that has never been broken or welded before. This is a brand new gearbox that I just added the plate to make it stronger. So I can show you a little more there. We get up here close. See, I cut an aluminum plate, 1/8 inch. I didn't want it to be thick because I was trying not to change it a lot. I was just wondering, like, what can I add to it without making a drastic change in the operation of the unit? This is a computer controlled unit, and I was being concerned about how particular a computer can be. I was concerned, that we would be doing something. If we changed anything more than, we should, we'd be doing something that might cause the whole car wash not to work. And I sure didn't want to do that. So I don't really think we can add a whole lot more than 1/8 of an inch. It does raise this brush up. And, eventually that's going to cause something to happen probably that's not good. So what we've got down there now, there's other gearboxes down there that have broke just like this one has, and they've been welded, and I added as much reinforcement as I could right here and then welded the plate on. So theoretically, some of those that's been welded on like that are probably stronger than this one. This one's never been welded here. It just got the plate added. But we're going to have to take this apart and fix it and figure out if we're going to do the same thing or try to do something different or what. Got it apart. This is as far apart as I take them apart to weld on them. I've never went as far. Some of these gears and bearings that are pressed on here, I've never went as far as taking that apart. And I've never had any trouble really welding on them. There is a seal right here that I don't want to get too hot, that I'm always being careful with. But one thing that's going to make a little work about what I did the last time is obviously the way this is broke. Even if we put a plate on it, we're not going to be using this plate. So I need to take this whole plate off. That'll be the first thing. And I'll gouge it off with a plasma, I guess. And while I'm doing that, it'll get some of the oil off this thing. Fan's running on that plasma. It's probably noisy, but I want to get you in here where you can see what I'm doing. If you look at the machine, I'm running the same air as I always run, but I've got the heat turned way down. So as I'm going along gouging here, I'm just kind of washing that weld off there. And then I find that separation in between the plate and the cast. You know, that weld looks like that. I find that separation between the plate and the cast, and I'm cutting the plate off there and removing the weld. We'll keep going on this and get that plate out of the way. This is a wild looking snake charming I got going on here. Got 7 clamps and 2 jack stands. I've cut a 1/8 inch aluminum plate, a new one. I did put the 5-inch hole in the center of the plate, but I'm not going to drill any holes in it yet. Look at this, what I got going on. The 2 of my clamps, where they were sagging in the back, I had to put jack stands to get them so they got the support they need to hold everything. But I've got everything in place, and those 2 pieces that I had broke off that I've got to put on there. A lot of times I try to puzzle piece parts together. I've said that before on the channel. I don't mess with them a whole lot. If they'll puzzle piece together, it helps me put them back where they went. And something I did years ago as a new welder, I would see something and I would immediately think that you got to bevel that to get a good weld. Well, I'd go and I'd bevel, and you do all this grinding and beveling, then you go to put it together and you don't have as much to line it up with, because you've ground away so much material that it's hard to see. And sometimes you can line things up that way. But I have better luck, most cases, just trying to puzzle piece things together. And in order to do the puzzle piece, you don't want to grind it very much. And when I went to put these together, they wouldn't go right together in puzzle piece. And that happens sometimes, and I'll tell you why I think it happens. When things break away, sometimes it changes the shape of the material a little bit. And when that happens, I'll sand just a little bit off of each side. Like the big bumps I'll try and eliminate, and then I'll try and puzzle piece it together. If I got to do some more, I'll do some more. But I don't take more off than I need to. And I can always go back in later and gouge it out somehow. And with aluminum, I usually end up using the death wheel, a metal cutting wheel on a grinder, which is extremely dangerous, and I'm not going to recommend anybody does that, but that's how I do it. And it's extremely effective on aluminum. So with the 7 clamps and the 2 jack stands, I do believe we're ready to tack this thing together. Done some welding, done some cleanup. I'm going to go back to welding. After I did the welding on here, I cooled it off. And you'll notice that you probably see I'm spool gunning this with a MIG. All the other casts pretty much that I've welded, I used the TIG, and I prefer using the TIG. This situation, as many times as these is broke and whatnot, I think I'm kind of in this case going a little more for quantity rather than quality of weld. I'm going to put some meat on there fast, get it welded up. It's not going to look as good as if I TIG'd it. There's more cleanup. I'm going to MIG around it. I'm going to go back and do some sanding, power brushing, grinding, MIG around it some more. It's just a faster way to weld. And knowing that these things have had so many issues, the precision of floating out every little piece of porosity that we can get by running the TIG, I don't think is going to benefit us that much on this. I think we get more of a benefit by putting as much weld on there as we can, as fast as we can, and doing it that way. So I'm gonna be spool gunning all this and seeing how it goes. Another technique that you can do if you have spool gun MIG and TIG that a lot of guys will frown on is you can put a bunch of beef on there with your MIG and then go back over it with the TIG. I'm not against doing that. I've heard guys badmouth other people about doing it, but you can save a bunch of time that way. And I know that taking the time to sit there and precisely float out every little bit of porosity and trash like you can with the TIG machine, you know, and be precise like you can with a TIG. That's the best way to do it. And on cast, especially, the TIG is the king. But in the case with this, we don't need that kind of precision. It's not benefiting us to float out every little piece of porosity as much as it would just put a bunch of beef on there, and we'll beef it up and weld it up, knowing that, you know, it's going to break again. And the ones that I've put a lot on and made them, you know, there's one of these gearboxes down there that I had built up quite a bit on, and it broke. It bent the arm on the car wash, and we had to, you know, we had to cut a 2x4 and jam under it, and then hook a come along from the arm down to the track and straighten it, you know, because it bent the arm. You know, it's one of them things where something's going to give. And the issue with these, especially in our area, the way those car wash brushes spin, you know, that's a great big old brush, and it's just spinning like crazy, and it's doing what the sensors, you know, the computer's following information that it's receiving from the sensors. And those sensors, you know, a lot of guys are pulling in there with these heavily modified vehicles, and there's signage all over the car wash saying that the modified vehicles are not allowed. But guys are coming in there with the big trucks and the big tires and the big Jeeps with the big brush guards and the big tires. And the sensors go around that front bumper. They'll go around that brush guard and get to the corner of that front bumper. And there's a huge space between this huge front pipe bumper and this big front tire. And the sensors tell the computer to send that brush in there and clean in that space. Well, you just imagine what happens when that big old brush goes in between that rubber tire and that, and you know, this pipe bumper. It goes from spinning at its full RPM to a dead stop. You know, it's just, and something's got to give. On these tips, when they get stuck with the aluminum MIG, I don't replace the contact tips in the aluminum MIG near as much as I do the contact tips in the steel. The melting temperature of the aluminum is a lot lower, and it just doesn't ever seem to burn the tip up. This one did get stuck, and you'll see I took it out and I snipped it so that there was about 1/8 of an inch of wire sticking out of the bottom. It was stuck on the end, of course, but when there's about 1/8 of an inch sticking out of the bottom, and then you grab it with your pliers and you tap that wire on the table, that 1/8 of an inch of wire that's sticking out of the back there is strong enough, it almost always gets it unstuck. And then I just use a torch tip cleaner and run through the contact tip. And I'm just mentioning this as if it's something that you'd want to save a little on. With aluminum, you can, because like I say, I don't see the contact tips on the aluminum MIG on the spool gun getting burned up like I do on the steel, and it stands to reason that they wouldn't, because the melting temperature is a lot lower on this. You just don't need to completely replace those tips. Not near as often anyway. I've made this one last a long, long time. I noticed at the top of that weld, here's some really bad ones. There's porosity there in that cast, mostly at the top. I'm going to take the TIG and try to do a little bit of repairs on those. I don't know how much time I'll really want to put into it as far as like fixing every little bubble. Probably won't do that, but we got to get it better than this. Okay, I I did some with the TIG and fixed some of the porosity. A couple things that I just want to touch on with aluminum welding. If you follow the channel, it'd be things you probably already heard. But one of the things is I use these sanding pads. I don't grind aluminum, even with aluminum grinding wheels. I either use the death wheel, which is actually a saw cutting wheel on a low RPM grinder. I don't put that on a high RPM grinder like a 10,000 RPM. This grinder, it just spins at a max of 3,500. And it's a variable, so you know you don't have to pull the trigger all the way. You can spin it from 600 to 3,500 RPMs. But when I use the sanding pads, you hit them with the beeswax. Get it spinning and touch it with the beeswax. That keeps the aluminum from galling up in your sanding pad. The other thing I use on the low RPM grinders is a stainless steel wire brush. And on aluminum, I use the type that is not knotted. You know, a knotted wire brush like this. I use these on steel. They're much more durable as far as, you know, being twisted up the way they are knotted. But I don't use those on aluminum because they're too aggressive for aluminum. And I don't power brush aluminum with a high RPM grinder. I use the low RPM grinder. You don't want 10,000 RPMs. You want one of these ones that doesn't go over 3,500. But one thing you need to be aware of when you run these, especially the wire wheels, especially that aren't knotted, all wire wheels throw wire. And that sucks. And you especially don't want it in your eye. But they're going to get stuck in you. If you look at my overalls, those are wires that were thrown out at high speed from the tool, and they're sticking in me. Sometimes they'll just be stuck in your clothes. Sometimes they'll be stuck in you. When they get you in the neck and stuff, it sucks, but life ain't always easy, especially for a welder. But anyway, I got that pretty much welded up, and I got to put it back together. And one thing I wanted to show you, that it never ceases to amaze me how filthy it is working this stuff. Look. This filth the sander, the power brush, the death wheel, everything, it just throws stuff all over your work area. And this is not an area where you would want to assemble something like that gearbox. You need to clean up. You don't want debris and metal and pieces of wire, and we don't want that. So I'm going to clean up and then we'll move on. There she is, all fixed up and put together. So this one now has quite a bit of reinforcement aluminum across the tabs, all four of the tabs where they break off. And it also has the plate, where the plate is, that 1/8 inch aluminum plate's added on there and welded all the way around. And I got to put a tag on it that says needs oil, because they'll have to remember to fill it with oil before they use it. But one of the things that I thought about the last time that I was down at the car wash, and we were looking at how, you know, there's a left and a right. And when they order parts, they have to get the right one. Like, you know, there's a left side and a right side. And this one will only go where it'll go, and it won't go on the other side. But I just did a test, and I think I found out that you could use any of these gearboxes on either side if you would take it apart and flip it over. What I'm meaning is that this hole pattern that bolts this cap on is exactly the same hole pattern that bolts the housing to this part that holds the worm gear. So if you were to take the cap, if you take the cap off, dump the oil out, take this plate off, take off a snap ring right here, pull this shaft out, take all the bolts between the housing and this housing out, flip this over and put it back together. You could reassemble it and use this same gearbox on the other side, I think. So I'll tell them about that if they ever get in a jam and need to try it. I'll try and keep them two gearboxes welded up at all times, where, you know, because you don't want the car on a pretty day. You can't have as expensive as it is to build a car wash like that and run a place like that. It's just not good if it's a pretty day. You don't want that thing broke down. That's no good, you know. Because it's not only like you're losing the revenue for that day, but all the people that come up there that have to wait, or all the people that don't stop because they see there's a big line or whatever, you know, it just makes their car wash experience more of a hassle, and they're less likely to come back. So, you know, that's one of them negative things that can be compounded. But we'll try and keep them some fixed up gearboxes. And my buddy did talk to a machine shop about this. They were talking about they could make him a housing out of stainless steel for this. I really don't know what, you know, I think that would destroy the car wash. You know, if it's that much stronger, you would really tweak that arm if you got it in a jam. But I don't know. Anyway, we got this fixed, and so far welding them up and fixing them like I've been doing seems to be the right thing to do, because if something has to give, as easy as this is to weld up, this is probably what you want to give. Because if we break that arm, you know, that's going to be a major deal. If that whole arm assembly's tweaked out really bad and busted up really bad, you got a major problem. But anywho, that's it for this one. So I want to thank y'all for watching, and remember, y'all learn how to work with what you got. That way you always have everything you need. Hey y'all, CB here in the break room at NBS Welding, coming to you with another merch video. Want to look at the merchandise, show you what we got. You can help support the channel by buying items. We got the NBS Welding t-shirts, got the NBS Welding on the chest on the front, got the great big NBS Welding here on the back, got the American flag on the sleeve. $25 plus shipping. Send Tina an email if you'd be interested in buying a t-shirt. $25 plus shipping. Send Tina an email, nbswelding@aol.com. The stickers. Got the small size stickers, $3. Medium sticker, $5. The big bumper stickers, $10. The coins, .999 fine silver. If you'd be interested in investing in the silver coin, got NBS Welding name and phone number on the front. Got the bull logo on the back. $50. $50 for the coins. Also with the coins, we've got the plastic case. Keeps the silver nice. Keeps it from getting fingerprinted and all that scratched up. The NBS Welding cups. Got the NBS Welding cups with the bull logo, and it says less yakking, more tacking. Got the QR code on the top. You can scan that. It'll take you to the NBS Welding YouTube channel. $27 for a cup. And I've had somebody said that I should sign the cups. I'm not doing that yet. I don't know if you want me to do that or not. But if you want a cup and you want me to sign it, I'll take a Sharpie and I'll sign it. I'll write whatever you want on there. Let us know. Send us an email. nbswelding@aol.com. Email Tina. And I'm not wearing an NBS shirt. I'm wearing a Kretschmer Excavating shirt. These are my buddies up in northeastern PA. If you need excavation work done in Wayne County, northeastern PA area, get a hold of my guy Cody up there. He can dig it. All right. I want to thank y'all for watching the NBS Welding YouTube channel. I appreciate all the support. Please continue to support, like, subscribe to videos, comment on the videos. If you don't have a comment, just go to the comment section, hit any letter, number, the period, whatever. The algorithm doesn't know the difference. Just, that helps support the channel. It helps get the videos out there. And y'all learn how to work with what you got. That way you always have everything you need.